So yeah, these are the editorials for Lead Code Weekly 382 contest. The first question is number of changing keys. Okay. In this question, you are given a zero index string, and what we need to do is we need to find the number of key changes. Now, a key change is defined when you change the specific key or the alphabet that is spelled. So, for instance, here there is one key change. You change from A to B. In this string, there is no key changes because the entire string consists of only B's. Now, a capital B and a small b, changing from a capital to small or small to capital does not count as a key change. So basically, it's mentioned here, modifiers like shift or caps lock won't be counted in the key changing, right? So yeah, let's look at some sample cases here. In the first case, there is AA, BB, CC, right? And the number of key changes are two, basically from this point, from here to here, A to B, and from B to C here. So total two key changes. And the length of the string is given up till 100. So those are the constraints for the length of string. So this question can be solved in a very simple way. So let's take an example string from the sample cases itself. We had this string, right? All right. What we can do is we can convert the entire string into lowercase, which means if it's already lowercase, it will stay lowercase. But if some of the characters are capital, they'll be converted to lowercase. So if I convert this to all lower cases, it will be something like this, right? Now what I need to do is I'll just run a for loop starting from I equals to 0, and I'll go up till I equals to n minus 1, where n is the length of the string, right? And okay, I'll say take one index basically. Yeah. So from I equals to 1 till I equals to n minus 1. And for each of those indices, I compare if s of I equals to s of I plus 1, that means that both of the characters are equal and therefore there is no key change, right? But in case s of I not equals to s of I plus 1, that means that the key has changed. So at this point and at this point, at two different places, we'll get this condition will be evaluated to true. And we can just maintain a counter variable and increase the counter every time such a condition occurs, right? And basically we can return this result also, right? So the time complexity of this question will be O of n, okay, where n represents the length of the string.